Hello James, welcome back to another video. This is question bank number 3, which means we are discussing the chapter motion in two dimensions. This is the question bank series for BITSAT 2025 that is keeping the grind on for BITSAT. Okay, so if you have missed out on the previous videos wherein we discussed question bank 1 and question bank 2, I highly recommend that you go back and watch those videos, okay, after you complete with this one. Okay, for those who are regular visitors of this series, you all know the trend. First of all, we discussed the previous year question trend, okay, which topic has higher weightage as per the previous year questions, okay, so that you know on which topic to narrow on and which topic to focus on from that particular chapter. Okay, so that is what we are going to do firstly, and then we'll discuss about 10 questions from that chapter to get a hang or to get the concept in our grade. Okay, so this is the premise of the series. Let's begin with the video. So let us look into the previous year trends. First of all, questions were being framed from vector algebra and general motion in two dimensions. 4 questions from there were being asked. Okay, so you'll get to know about the questions more when we dive deeper in this video. Then we have projectile motion. About major section of this chapter is projectile motion, right? About 90 to 95% of this chapter is plainly projectile motion. So most of the questions come from there, and that too I have narrowed it down for you. Most of the questions are from ground to ground projectile motion or equation of trajectory. Hardly 1 or 2 from equation of trajectory, rest from ground to ground projectile motion. So your formulae of maximum height, the time of flight and range become very important. Okay, you are going to manipulate them to get to your answers, as you will see in the questions. Then projectile motion from a height, as such no questions being asked from there. Okay, then you have one question from projectile on an inclined motion, so slightly modification to your height and your time period formula, right? You might know projectile on an inclined motion and then inclined plane. Then we have finally relative projectile motion, which makes it actually very simple, right? You don't have to consider gravity if two projectile motions, you are considering one relative to the other, right? So one question from there as well. Then we have relative motion in two dimensions, like the Rainman problem or reverse swimmer problem. Okay, also 2 questions from there. Okay, so that was the previous year trend. Enough of talking, let's get into the questions and let's try to solve them. 1 and 2 over here. In question 1 we are given the coordinates of a moving particle. The x coordinate is given, y coordinate is given. So motion in 2 dimension, right? X and y we have. You are supposed to tell the speed of the particle at any time t, right? In order to obtain speed from the coordinates, you differentiate it, right? So velocity in the x direction will be dx by dt, right? So if you differentiate this once, we'll get the velocity in the x direction. So differentiate this t cube, right? Alpha and beta are constant. So t cube, we have 3 alpha t square, right? T cube, the differentiation is 3t square, okay? N upon n t raised to n minus 1. Okay, here similarly dy by dt will be 3 beta t square. Okay, now you can write it in the vector form. Okay, this is unnecessary, but just to give you an idea. Okay, so this is vx I cap plus vy j cap, right? So vx I cap is this bt alpha t square I cap plus 3 beta t square j cap. Okay, if you were given certain value of t, you would have substituted it over here and you could find the value in terms of a constant value, right? You won't have the t value. Okay, there'll be some value for it. Okay, but here you are supposed to find at any time t. Okay, so you'll consider directly this, no need to substitute any value. So this is your x component, y component. Okay, and how do you find the magnitude? The magnitude of this will be this square plus this square, right? So 3 alpha t square the whole square plus 3 beta t square the whole square. You can see that this 3t square squared, 3t square squared is common, and you can take it out of the root sign. So you will get out of the root sign 3t square, right? It is squared, whole squared, and that square root will get cancelled. You can work it out and you will be left with alpha square plus beta square, which is option C. Okay, 3t square alpha square plus under root of alpha square plus beta square. Let's come to this one. This is some relative motion in 2 dimensions. So we have a man who is walking on a horizontal road, okay, with a speed of 4 kilometers per hour. Okay, and then suddenly we have rain which is falling vertically downwards with a speed of 7 kilometers per hour. Okay, you're supposed to tell the magnitude of the relative velocity of the rain with respect to the man. Okay, so the man is watching, right? With respect to the man, the man is watching the rain or is walking, and the rain is coming to him. Okay, so basically you can imagine the scenario, right? He's walking, or you can picture running, because that will better help you understand. If he's running and the rain is falling vertically, he'll perceive as if it's coming towards him, right? It's running towards it. So the rain is falling vertically, he'll perceive it somewhat like this. Or the concept of relative motion you can use. This is 7 kilometers per hour, rain is falling down, and you are watching in respect, the man is watching the rain, right? With respect to the man. So you can flip this velocity and give it to the rain. Okay, so this will be something like this, right? Now you can draw the resultant. As I told you, it's like coming towards the man, right? So this is the concept of relative motion. Whatever you are watching with respect to, you flip its direction and give it to the ray. Okay, give it to the other one. So flip and give, right? Flip and give. That is what I used to say in my lectures. So this is the resultant, right? 7 and 4, resultant of that. How do you find the resultant? The same method, right? So the angle is 90 degrees, so you can just add the square and take the square root. So 4 square plus 7 square, okay, and square root of that. So this is 49 plus 16, right? 49 plus 16. So that is 55, 65, 65. So around 65. So 8, okay, or it's given in those units only, okay, root of 65. So root of 65 and kilometers per hour, of course, okay. So that's about these two questions. Over to the next one. Question 3 over here, we have a projectile which is projected. A particle is projected at some angle. Let us suppose it is theta. It has the time of flight t1, okay, and it is given that it has range r, okay, some range. Okay, then we have the same particle which is projected with the same speed at some other angle, okay, and the clue is that they have the same range. Now when does two angle will have the same range? Provided the velocities are equal, okay, same speed for the both cases, but the range is same, okay, same speed, two different angle but the range is same. When does this happen? This is a special case. This happens when the angles are complementary, meaning 60-30, 70-20, okay. So these angles basically, if you see that they add up to 90, okay, or you can have anything random, okay, two angles that add up to 90 will have the same range provided they are thrown with the same velocity, okay, 60-30, 70-20, or 45-45, that is obvious, or we can have anything. Basically you can have 65-25, okay, just right. Okay, so basically two angles which are complementary that add up to 90 will have the same range. So if we take one angle as theta, for the other one to have the same range, we will take it as 90 minus theta. Okay, so that is the only trick over here, or pi by 2 minus theta also you can take. Okay, so this will have the same range r, but the time of flight will change t2. Okay, you are supposed to tell which of these relations is correct. First of all, you can directly eliminate a and b. If you see, the dimensions on the left hand side is of that of time, and here it is nowhere close to time, right? This is not time, this is not time. Okay, so you can neglect that. So you are just supposed to take the product, right? First of all, we can find t1. T1 will be let's find r first. Okay, let's find r first, because r is same for both. Okay, it's mentioned in the question. So it's u square sine, this is the formula, u square sine 2 theta by g, or I'll write it in the expanded form. Sine 2 theta I can write as 2 sine theta cos theta, right? So 2u sine theta cos theta by g. Okay, this is our value of r. Okay, then what can we do? Then we can write for t1. T1 is 2u sine theta by g. Okay, 2u sine theta by g. Simple formula, right? Projectile motion angle theta, 2u sine theta by g is the time of flight. And t2, what will be that? So 2u sine 90 minus theta. Now the angle of projection is 90 minus theta. Sine 90 minus theta is cos theta, okay, by g. Now you take the product, because those are only the viable options among which you have to select, and compare it with r. Okay, so if you take the product, this will become 4 u square sine theta cos theta by g, right? And you can write this as 2r by g, right? 1 2 you can absorb in this formula, right? This is r, right? So 1 2 will remain, and u square sine 2 theta sine 2 sin theta cos theta by g is your r. So this whole thing is r. Just remove 1 2 from there, and I think this is g square, right? When you multiply this 2, this is g square. This will have g in the denominator. Okay, 1g is there in the r. So option B, 2r by g is the correct choice over here. Okay, the key concept was two complementary angles will have, for the same velocity, will have the same horizontal range r. Question 3 and 4, we are halfway there. So question 3, we have the equation of trajectory. Now this is an important concept that you can remember for questions wherein you are given certain points, okay, 2 comma 3, suppose x and y is given, and then you might be asked for angle of projection. Okay, in those cases you are supposed to remember this equation of trajectory. Okay, it's quite useful, so keep it at the back of your head. Okay, now in this case it is directly given x and in form of x and y, you are supposed to tell the speed of projection. Okay, in general the equation of trajectory is x tan theta. There is a much complex form than this, but this is a simpler form. You can remember this, gx square upon 2u square cos square theta. Okay, now you can compare this equation with that. So if you see, coefficient of x is, here it is tan theta and there it is 1. Okay, nothing means 1 is there. Okay, so theta, this implies theta is 45 degree. Of course we take the acute angles only for projectile motion, and then for this minus sign is there, then this g by 2u square cos square theta will give you 10, right? So I have compared this coefficient with this. Okay, now g is taken as 10, so this and this can cancel, it's mentioned. So 2u cos square theta should be equal to 1. Okay, cos, you know that theta is 45, cos of 45 is 1 by root 2, and that squared is 2, right? So this 2 and that 2 will get cancelled. So this is 1 by root 2 and that squared, right? So this and this will get cancelled. This is 1. So u is plus or minus 1, but doesn't really matter. Speed is 1 meters per second. Okay, so speed is asked. So it is 1 meters per second. Okay, so you can obtain it from the equation of trajectory. Okay, so remember this general form. It's quite simpler than the one more complicated. Okay, there is also a form in the form of range you can obtain, but let's not take the discussion there today. Okay, so the value of linear velocity, it is given, you are supposed to find it for omega this and r this. Okay, the simple relation for linear velocity from omega and r is omega cross r. Okay, not the other way around, it's omega cross r. If you do r cross omega, you will get the negative answer. Okay, so v is omega cross r. Okay, so you are just supposed to take the determinant, right? So the cross product basically, I, j, k, and omega comes first. Okay, omega then r. So omega, so in exam they might give you r and omega. Okay, so that time you have to take care that omega comes first and then r. Okay, follow the order. Okay, so then we have minus 4 and 1. Here we have 5, minus 6 and 6. Okay, so here I cap. Now I hope you know to solve how the determinant. So you close this and this. 4 6 are 24, that with a minus sign, minus in the between, plus this 6, right? So minus j cap, it's always minus j cap, right? Then we have close of this and this, 6 3s are 18, minus 5, plus k cap. Okay, close of this and this, 3 6 are 18 with a minus sign, and 4 5 are 20. This minus and the minus in between makes it plus. Okay, so you could have actually compared only the first coefficient. If you see, only this one will give you, this one will directly give you minus 18, right, which is only there in this option. So here we get 13 j cap, and finally this is plus 2 k cap, right? So if you see, this is not matching, but I think this should be, there is a mistake, printing mistake. This should have been minus. Okay, so I think that is correct. Okay, you can check it, recheck it if I have made a calculation error, but I believe it's correct. So that's from these two questions. Over to the next one. Question 6 and 7 over here. In question 6, quite a good concept is used. Here we have been given the velocity of the projectile resolved in x and y direction. So alpha x cap and beta y cap. Okay, so here we have the resultant projectile motion. You are supposed to tell the time of flight. Okay, actually you can do it via intuition also. let me ask you this question: which component is responsible for the flight? Okay, you can see that clearly the y component is responsible for flight, right? X component alpha is responsible for range, y component is responsible for the flight, you can see. Okay, so only this one is the correct choice over here. Okay, you can actually derive it. Okay, let's uh, rigorously do that. So you can actually use the equation of motion. I'll also show you other way around: uyt plus ut plus v is equal to u plus at, right? What am I doing? Okay, so this is the equation. I'm using it in the y direction. Okay, so that is how you find the time of flight. Okay, if you remember the derivation. Okay, you will take the time up till from here to here. What is the time for the velocity in the y direction to become 0? You can see that gravity is acting in the downward direction, right? So this beta component, there is deceleration in the y direction, so it goes on decreasing, and at this highest point the velocity in the y direction is 0. That's why it is the highest point achieved. Okay, it cannot go beyond that because there velocity in the y is 0. Okay, so it cannot go beyond that. So that is the concept. Anyways, so velocity in the y is 0, initial velocity in the y direction beta, acceleration minus g, right? Beta is like this, g is like this. Okay, and this is the time. Time will be given as beta by g, right? This is the time to reach the maximum height. Now parabola is symmetric, right? So if this is the time to reach to the maximum height, from maximum height to ground, it will be 2 times of this. So the time of flight will be 2 beta by g, as I told you, right? Or okay, if you don't want to do this, if you don't want to you don't remember how this time of flight is derived, okay, or you directly remember the formula, that is time of flight is 2u sine theta by g. Okay, what is u? U is this, right? The resultant vector that you get. Okay, or in this case it is v. Okay, but let's take it u, avoid the confusion. Okay, so it is the actually the square root of alpha square plus beta square, right? So the magnitude. Okay, so but let's not we'll keep it as u only. Okay, so what do we want? 2u, and sine theta. Sine theta, if you obtain from this triangle, this is theta, right? So obtain from this is beta, right? This is alpha and this is u. Okay, so sine theta will be beta by u, and this is g, u cancels, 2 beta by g, as simple as that. Okay, so you could do it anyway, your choice. Let's come to this one. 2 bullets are fired from the same, so they are fired horizontally, which is important, from the same position basically. Okay, one with some greater speed than the other, okay, and one with lesser speed. Okay, so some different speeds. Okay, so surely one is bigger than other. So you are supposed to tell which bullet will hit the ground first. Faster one, slower one, depends on the mass, or both will hit simultaneously. It's quite clear, right? So suppose we say this v1 and v2, they are horizontal velocities. They are not contributing to this motion in the vertical direction. Which will hit the ground first? Both are starting at height h, right? And both the force of gravity is same, right? Or the acceleration due to gravity is g on both. Okay, so in the y direction, it's the same thing for both of them. They don't have a velocity component in the y direction, right? So for both of them, it's same g acting in the downward direction, and that will create a velocity, bringing it down, right, in that direction. Okay, and both will hit simultaneously because the y component for both is produced by this g. Okay, so both will hit simultaneously. Easier concept. Okay, and of course there is no air resistance in this case. Okay, so that was mentioned in the question, so I found it worthy to be mentioned over here. So that's about this 2 questions. Over to the next one. Question 8 and 9 over here. Okay, so question 8, we have a bus which is going in the north direction with speed of 30 kilometers per hour, and then it makes a 90-degree left turn without changing the speed, so 30 kilometers per hour, and then it turns left and also 30 kilometers per hour. Okay, I'll draw it in the vertical plane, but remember that north, south, east, west is in the horizontal plane, right? So I'll refer this top direction as north, down is by default south, and we'll have this as east, right, and this as west. North, south, east, west. Okay, now initially it is traveling, so u I can write as, so I'll consider the usual x and y axis. Okay, so u I can write as 30 j cap, right, in the north direction, initial velocity, and final velocity. Okay, it's only in the, it turns left, and this is in what direction? Negative x, right? So it's minus 30 I cap. Okay, so change in velocity is basically final minus initial. You can do delta v, we can say this is the change in velocity, final minus v minus u you can do. Okay, and then find the magnitude. Okay, that is what is being asked in the question. Okay, also you can the direction is quite simple, so it was going north, then it changed like this. Okay, so what is the resultant? Resultant is in this direction, right? It is in the northwest direction, northwest, right? So it is in the northwest. Only one option is northwest, so that has to be correct, but we'll also justify the value. Okay, so this is 30 30. Okay, it's in different directions, so v is minus 30 I cap, and this is minus of this formula, and we have 30 j cap. Okay, so this is the change in velocity. Okay, now we can find the magnitude. Magnitude will be 30 root 2, right? 30 square plus 30 square, so that is 30 root 2, right? Basically a square, the diagonal is so s you have, this is s root 2, right? For a square, diagonal is root 2 times the side, so 30 30 will give you 30 times root 2, or you can use Pythagoras. So you'll basically get 30 times root 2, which is this value. Okay, so if you want to see that, root 2 is about 1.414, right? And into 3 we can do, and then we'll shift the decimal. 3 4s are 12, 3 1s are 3, and 4, 3 4s are 12, again 4 2 4 2. Okay, so we'll have the decimal over here, and there is 30, so 42.42. Okay, so that is 42.4 kilometers per hour in the northwest direction. Okay, so that's your answer. Now here I don't have the question in exact wordings, but I'll make you understand the scenario. So here we have two projectile motions, so it's a case of relative projectile motion. One is launched at an angle of 30 degrees, okay, and it has speed v1, okay, at h max, just below h max. H max is the maximum height this projectile will achieve. Okay, so just below that we have v2, okay, another projectile which is launched with a velocity v2. Okay, you are supposed to tell the ratio of this v1 by v2 so that these two projectiles will collide. Okay, this is happening. Okay, so if these two have to collide, what is this ratio v1 by v2? Okay, now it's the case of relative projectile motion. You can see that on both, on this also we have g, on this also we have g, right? So we can go in a frame, okay, and just neglect this g. That's why I was saying the cases of relative projectile motion becomes quite simple, right? Because both are under gravity. We can, while watching from the frame of one, the motion can be considered as just uniform motion. Okay, we just cancel out the gravities. Okay, or you can remember the concept of flip and keep, right? So if you're watching with respect to this, flip its gravity and give it to this. So that g and this g will get cancelled. Okay, so anyways, that is the concept of relative motion, relative projectile motion. So now we no longer have gravity in action. Okay, so what is the question? Why? What is the condition between v1 and v2 so that these two collide? Okay, so it's quite simple. You can see that both should have the same component of the y velocity. Okay, so if they have the y velocity same irrespective of the x, so y velocity is same, they will reach the same height in same time, right? So for this v2 and the y component of v1 should have the same value. Okay, so that they collide. Okay, so that they travel that equal distance, right? So v1 y component and v2 should be equal. Now what is the y component of v1? So opposite to theta is sine theta. Okay, so v1 sine theta, or I can say sine 30, right? v1 sine 30 should be equal to v2. You are supposed to find v2 by v1, v2 by v1, right? So be careful. Sometimes they might ask v1 by v2. Okay, so you have to be careful what the question is. So sine 30. So v2 by v1 is half. Okay, sine 30 is half, right? So simple concept. The y component of both the projectile had to be equal. Here it's v2 is directly in the y direction, right? There is no x and y component. So yeah, so the correct choice is option B, half. Okay, that is the ratio for collision. So in question 10, the final question, we have two particles. One is moving from A to C, other one is moving from A to D. Okay. In moving these distances, if the time taken by these two particles are same, the ratio of the magnitude of their average velocities. Okay. Now the key word over here is velocities, average velocities, right? What is average velocity? Average velocity is the total displacement upon time taken, right? Total displacement, not distance. Okay, that is the key over here. The time is same, so we'll take it as t. Okay, so total displacement upon time taken. So what is the displacement for this particle which goes from A to C, this distance AC. Okay, and what is the displacement for this A to D, right? It's not this arc. You are not supposed to find the distance of the arc. Okay, that is not useful over here. Velocities means displacement. Okay, so objective is to find AC distance and AD distance. If we can find that using some geometry, we are good to go, right? We can find this ratio. So how to find AC? First of all, we can remove this triangle A. I'll connect this and this. Okay, so I'm removing this triangle AC. Okay, O is somewhere over here, right? And this. Okay, this is O. Okay, you can see that this distance AO will be the radius, AB is the diameter, right? Okay, it's not mentioned, but okay, AB is the diameter, it is passing through the center O. Okay, and you can see that AO will be the radius, also OC will be the radius, center to the point on circle. So this is also the radius. Okay, so if this is 30 degrees, this will be also 30 degrees, right? This is the property of isosceles triangles. Okay, so the sides are equal, opposite angles are equal. Okay, so this is R, this is 30, R 30. Okay, so what is this remaining angle? Angle sum property 30 30 is 60, 60 minus 180. Okay, 180 minus 60, that is this angle, this remaining angle over here will be 120. Okay, is that relevant over here? Okay, yeah, it is. Okay, so what I'll do, I'll drop a perpendicular from this O to this. Okay, so we can break this isosceles triangle into two similar triangles. Okay, so here we want this distance, okay, AC. Now I'll call this distance from here to here. Okay, when I've dropped the perpendicular, this distance is x. Okay, we are supposed to find 2x. Okay, basically these two are congruent triangles, you can see. So this side is equal to that. So we will find x and we'll get 2x, right? So that will be the distance OC, sorry, the x. AC, sorry. So here this angle is 60 degrees. Now I dropped a perpendicular, right? So these two sides are equal, meaning this angle is also cut into half. So 120 half is 60 degrees. Okay, or you can again use angle sum property. This is 90, this is 30, so this has to be 60. Okay, so now do we know this side? This is O, this is something random, this is C. Okay, we know this side. So what we can use sine 60. Right, sine 60 will be opposite upon hypotenuse. So it is x by r. This is root 3 by 2. So x is root 3 r by 2. Okay, and we want AC. AC is 2 times x, right? AC is 2 of x. Okay, 2 times of x. So this 2 and this 2 will get cancelled. Okay, and we'll have root 3 times of r. So this is the AC distance, or now we can find the velocity of this velocity along this for this particle VAC. So it travels a displacement of root 3r and time taken is some t. Okay, we'll keep it same for both the particles, right? Now let's focus on this triangle because we want the distance AD now. Okay, now that is very simple if you see. So here it is A, here it is O. So again this is radius. Here we have something like this. Right? This is D. If you see OD, right? So it is also R, OD, center to the point on circle. So this is R, this is R, this is 60, meaning this is also 60. Okay, angles, isosceles property, and so the equal sides, opposite angles are equal. So 60, 60. So basically this is a equilateral triangle, right? 60, 60, this will be also 60. Okay, and so equilateral triangle meaning this side will be also R, 60, 60, 60. Okay, everything becomes 60. So this AD distance is R. Yeah, I hope that is clear. So velocity along this AD for the particle that travels along AD, displacement is r and the time taken is t. Now we are supposed to find the ratio. Okay, we'll find AC by AD. Okay, or we can also find the other way around, but both the options will not be present in the, so r by t will get cancelled and you'll have root 3, right? So if you see 1 by root 3 is not present, so if you had taken the ratio other way around, that won't be present in the options. Okay, so you are supposed, they are presuming that you take the ratio of this by this. Okay, if you don't get the answer, you just take the reverse ratio. Okay, so yeah, so option C is the correct choice over here. Root 3 is your answer. So just included a bit of geometry, okay, and some logic, right? So that's about this question bank. I hope you really enjoyed it. If you haven't watched the previous question banks, do go and give them a watch. We'll continue with this grind. We'll continue with this series up till your BITSAT. I'll be there with some other series helping you strategize and help you crack it this time. Okay, so if you are interested, do consider subscribing. I'll see you soon in the next video. Till then, keep enjoying physics.